This is practice A for section 1.3. We're going to look at those last two questions, number 25 and 26. So for number 25, they say your house and your school are 8.4 miles apart on the same straight road. A baseball field is halfway between your house and your school on the same road. So if they're on the same road, we're talking about 3 points that are collinear. That baseball field is halfway between your house and the school. Now if it's halfway in between, that means it's the midpoint, so I'm going to indicate that with these marks. This first question says to draw a sketch to represent the situation. Well, we got that. We got a house, a school, a baseball field. We know the baseball field is directly in between because of these marks. How far is your house from the baseball field? Well, house to the school was 8.4 miles. And if that's halfway, if we take half of 8.4, it'll give us 4.2. That's how far the house is from the baseball field. And it's also how far the baseball field is from the school. And this is in miles. Units are important. Now it also says that you walk, for part B, you walk an average speed of 3 miles per hour. About how long would it take you to walk from your house to the baseball field? That might sound confusing. But if you can walk 3 miles per hour, that means after 1 hour of walking, you've gone 3 miles. Okay, well, we want to walk from our house to the baseball field. That's 4.2 miles. If we walk 3 miles an hour, after an hour, are we going to get to the baseball field from our house? We're not. Okay, now if we walk for 2 hours, we would go 6 miles. Okay, so it's in between 1 and 2 hours. So you need to figure out how many times that 3 goes into 4.2. Okay, now if you read it like this, 4.2 miles divided by 3 hours, notice how that gives us a unit when we divide of miles per hour. So what is 4.2 divided by 3? Okay. 1.4. I messed this up. This should be miles per hour down here. So our unit for our answer is 1.4 hours. That's how long it takes you. And you might not know how long that is. Well, 1 hour is 60 minutes. How long is 0.4 of an hour? Well, what is 0.4 of 60 minutes? That's 24 minutes. So this is really 1 hour and 24 minutes. For number 26, the diagram shows the position of 3 soccer players. We have an A, a B, and a C. Player A kicks the ball to player B. Player B kicks the ball to player C. How far did player A kick the ball? How far did player B kick the ball? So what we're doing is we're measuring these distances from A to B and then from B to C. So you need to find distance from A to B and you need to find distance from B to C. Also, it says how far would player A have kicked the ball if she had kicked it directly to player C? So you also need to find the distance from A to C. it says round all answers to the nearest tenth of a yard. We've been doing the thing where we round to the nearest hundredth for everything. Okay, so if you want to do that, you can as well. Tenth would be 1 decimal place, hundredth would be 2. Okay, so how do you find distances on a coordinate plane? Use the distance formula. And you're going to have to do it 3 times. Okay, so I'm just kind of filling in that skeleton for your distance formula. And then what you need to do is plug in the coordinates and then type it in your calculator. Okay, so from A to B, look at your x values. We have a 3 and a 12. We'll put those there. I put the 12 first. Now, your y values, we've got to subtract those in the same order, so we'll do 14 minus 18. Now, you need to type that in, and you need to know how to type that in. So, second, x squared, that gives you that radical. And then in the radical, we're doing 12 minus 3. I'll put 13. Then we're going to add 14 minus 18. Here's our distance from player A to player B. It doesn't really say, oh, it says distance in yards. Okay. So this would be how far player A kicked the ball to player B. 9. It would be 9.8 if we're rounding to the nearest tenth. If we're rounding to the nearest hundredth, we would actually take that 84 and make it an 85, because that third digit is 5 or bigger. Okay, now let's do the same thing for player B to player C. Now, we're using the same 12 and 14 that we used here. So if you're smart about this, you can keep those in the same place, and I'll show you a quick way to do it on your calculator. Okay, so we need to do 12 minus the 17, and we need to do 14 minus the 6. Okay, so if you go back to your calculator, instead of typing the whole thing in again, if you hit second, enter, you get the same exact expression, and then you can come back and kind of switch some numbers out. So I want to do 12 minus 17 instead. I have a 3 there, so I need to change it to a 17, but if I type my 7 right now, I'm typing over the other part of my formula. So I'm going to insert. Insert is that INS function. So I'm going to hit second and then delete, so I get that insert 17. Okay, so I'm not typing over my formula. And then I can just kind of scroll out of there with my arrow keys. Okay, I need to do 14 minus 6 over here. Notice how I have too many characters. I got a 6. Well, now I can delete the character. So this one button right here is really important. It's a delete button and an insert button. Okay, so there's your distance. If you round to the nearest tenth, it would be 9.4. If you round to the nearest hundredth, we would call it 9.43 because that third digit is not 5 or bigger. Last one. We need the distance from A to C. So we already have our coordinates from C in these positions, so if we keep those, we'll save some time and some brain power. We need to incorporate player A into this. This is the X value. This is the Y value. Okay, so let's try that shortcut again. I'm going to do second, enter, and then I'm going to swap out some values. I don't want that 12. I want a 3 this time. So I'm going to put a 3 there and delete the other character. I don't want the 14, I want an 18, so I can just go over to that 14 and I can just make it an 18. Okay, now this should make some sense. this is a much bigger distance, A to C, than either of the other two. Okay, we'll round that to 2 digits. We'll call it 18.44. It was 43, but that 9 is bigger than 5, so we'll make it 44.